Hi, this video about the starduster antenna and modeling is in response to a thread post on the worldwidedx forums. It started with a Cybolt who mentioned talked about all this discussion over a quarter wavelength antenna, to which I responded something along the lines of, "That's a very common opinion," referring to the starduster being a quarter wavelength antenna. And I mentioned that the fact that the radials are angled down can be used as a good argument to state otherwise. I also continued on that it doesn't really matter over ground or in the real world that we have, as any antenna with the same tip height is going to have very close to the same amount of gain. And if you even notice the difference between two different antennas, you have a problem with one of them. A few posts later, Marconi said that even though I said what I said about it not making a difference, he would like me to present my views on this. So here we have a quarter wavelength ground plane in free space. I know the starduster antenna has 3 radials, and I'm using 4. It's much easier to use 4 radials than 3 in this software. I can do 3 radials, but it's a lot of extra work for what's really going to end up being a very small difference in the end anyway. But here we have our baseline in free space. Yes, I'm doing free space, and I know some people scoff at that. But free space is, starting with free space because free space shows us what the antenna will do on its own. If we're going to compare this antenna to anything, I have stated in the past that this antenna, as you angle the radials down, acts more and more like a dipole and less like a quarter wavelength vertical antenna. If you have the dipole and the quarter wavelength vertical antenna over ground, they have about the same gain. However, as we can see in free space, they do not. Quarter wavelength vertical antenna has, in this case, 1.56 dBi of gain, and we all know that a dipole has 2.15 dBi in gain. Therefore, I wanted to say 2, but I'm going to say 3 things is going to happen as I take this model and begin to angle the radials down. 1, it's going to continue to act like a quarter wavelength antenna, at which point the gain will stay pretty close to being the same. Another possibility is as we angle the radials down, it will get closer and closer to acting like a dipole, which means the gain will steadily go up. And as we angle the radials down further, the gain will get closer and closer to that of a dipole. The third option, both of these are entirely and completely wrong, in which case something else will happen entirely. That option isn't very likely. So, starting with a quarter wavelength vertical with horizontal radials, let's add in, give me a second, it's a bug with running this program in Linux. Let's add in a model that has the radials angled down. Our gain has gone from 1.56 to 1.67. As we can see, the radials are angled down. In this case, 20 degrees. These are 20-degree down angled radials. Gain has gone up, but not significantly. So far, this is inconclusive. Let's add in another model. Free space minus 40. So we can see in this added model, the radials are angled down further, and this continues, 1.85. And as we continue to angle them down further, one more, we're up to 2. And 2.1. So at 80 degrees, we're at 2.1. This is a fairly steady increase in gain as we angle the radials down. This is saying, I think, as conclusively as far as modeling can show, that As we angle the radials down, the antenna acts more and more like a dipole. This wasn't my argument. This was me saying an argument can be formulated based on this. Continuing on. What happens if we take these and put them over a ground? So here I have a quarter wavelength antenna. It's actually about a wavelength above the ground. I have designed these so that in all cases the tip height stays the same. The tip height is the baseline, and the length of the antenna and the angle down radials are all calculated based on the tip of the antenna, not the feed point like I normally do. This way I can consistently represent, or I can represent with models, what happens with the different layouts with the same tip height on the antenna. Again, we have horizontal radials. We're going to... Oh, wrong one. We're going to do those later. Minus 20 degrees. Same antenna with a radials angled down. In this case, we also get slight addition of gain, but you notice it's a lot less than it was before. Minus 40 degrees, so we angle the radials down further, and the trend continues. It's still more gain, but unlike free space, it's not as much more gain. Minus 60 degrees. Minus 80 degrees. As we can see, and again, the radials are angled down pretty far. As we can see, gain still continues to go up. But it's not as drastic as before. The ground is definitely asserting its effect on these models. This is more evidence. It's not just acting like a quarter wavelength antenna, it is in fact acting like a dipole antenna. Now we're going to switch to a more realistic, in some people's minds, idea of modeling an antenna over a ground. Here we have quarter wavelength antenna, horizontal quarter wavelength radials. We have a mast that goes all the way to Earth. This blue dot is a choke. It's simulating an air choke that would be on an antenna. So we have a choked quarter wavelength vertical with mast that connects directly to the Earth. What happens when we angle the radials down in this case? Angles radial down, and actually in this case gain is actually beginning to drop slightly. Pattern, minus 40 degrees with mast. Gain continues its path of dropping, but you'll note it's also still very small change. We're going to go minus 60 degrees with mast. And gain continues to drop. And finally, minus 80 degrees with mast. So as we can see here, when we add a mast that goes straight down to the Earth, gain actually drops. So, in conclusion, what we've seen is, in free space, angling the radials down does in fact show that this antenna acts more and more like a dipole. However, once you add an Earth, we notice that the changes in gain is less and less. The one exception is in this last one with the mast, the radials angled down at 20 degrees. We see a pretty significant drop off from 60 degrees down, 3.78 to 3.29. That is most likely because of the effect of them being close to another piece of metal, in this case the mast. As you get closer to the mast, that will have more and more of an effect on the antenna. But aside from that, the actual gain difference is very small once you factor in a ground. And that's that.